Welcome, everyone, and thank you for joining us here today for this webinar discussion. My name is Philip Reiner. I'm the CEO and co-founder of the Institute for Security and Technology. We wanted to say an immense thanks to everyone who's on the call with us here today, but also to our panelists and to our moderator. I know things are a little bit, well, things are pretty crazy in the world right now for folks who are trying to deal with the fallout of everything associated with SolarWinds. So we really appreciate you making the time to be here to talk with us. Just a real quick word on IST and who we are. We're a West Coast-based think tank that's focused on technology and security issues. Our whole goal is to do everything that we can to bring together the two worlds of folks who are building technologies and deploying them together with those who are working on national security policy. And so if you're interested in learning more about what we do, don't hesitate to reach out. Happy to connect and give you a little bit more background on who we are and what we're up to. Have a really great panel here for you today to talk about some issues that I think are of great import to everything that's going on in the world right now. Just a quick set of introductions, and then we'll swing right into things. In terms of logistics, the way this will work is our moderator, Ali Gulshan, will run the conversation at the outset, engage in some back and forth questions and answers with the panelists. And we'll be sure to, some of you have already submitted questions via the RSVP process. We'll be sure to incorporate those into the discussion. If you want to get in touch, hit us via social media, hit us on Twitter, wherever, and we'll incorporate those questions into the discussion as well. We want to make sure to make this as much of a back and forth as possible and reflect the things that you all are interested in. So thanks for those questions that have already been submitted. Real quick background intros on our panelists here today. We've got Amelie Karan coming to us from Splunk. She's the senior technology advocate there. She's the former chief technology officer at HHS, so that's the Department of Health and Human Services in the Office of the Inspector General. Super excited to have you with us. Thank you for being here. Dan Tentler coming to us. He's the executive founder of the Phobos Group, which provides boutique information security services specialized in attack simulation, remediation, incident response, virtual CISO services, probably not busy at all right now. Has been working in the field of computer security as it's posted online since 2008. Super excited also to welcome Michael Medellin coming to us from Kessel Run. Those of you who are on the call who may not be familiar with Kessel Run yet, I'm guessing that may come up in the course of the conversation today. Super excited to have you here, Michael, to talk about Kessel Run and what you're all doing there. He's a director of engineering there, formerly the principal product manager at Synacor, cloud-based software and services company. Great to have all the panelists here, and we are super excited and genuinely appreciative for Ali Gulshan to be here with us today, who is the co-founder and CTO of StackRox, where he oversees the technology strategy and roadmap. Previously a founder and CTO of Cyfort, which was acquired by Juniper, was a security researcher and engineer at Microsoft, PwC, previous to which he served in the intelligence community. Really excited to have this conversation. You guys, I think it's of critical importance to everything that's going on out there. So why don't I stop with the introductions and turn it over to Ali. Look forward to the discussion. Thanks again for being here.
All right, thank you. Thanks everybody for joining today. I'm really excited for the panelists today. As everybody knows, the topics today are really going to center around DevOps, DevSecOps, and leveraging containerization in Kubernetes and how they've expanded a lot of use cases as far as security goes, but as also as sort of the exposure of some attack surface that comes with it. So we would love to sort of dig in and figure out how everybody on this panel is thinking about it. So maybe we can kick it off with Michael. Actually, since Kessel Run came up, maybe you can kind of kick us off by telling us a little bit about Kessel Run and sort of giving us an overview of how Kessel Run thinks about DevOps, Kubernetes, and how you've incorporated it into your overall programs.
Sure. Yeah, thank you to IST for putting this together. Really looking forward to the conversation today. So yeah, background on Kessel Run. Kessel Run started in early 2018, kind of around some of the efforts that were going on elsewhere in the government to modernize infrastructure, and the DoD kind of got wind of all of these efforts and plucked a couple of different projects that were happening elsewhere in small groups and put them together and formed a group called Kessel Run. primarily focusing on the air operations centers around the world and focusing on their software that they use to conduct their mission on a day-to-day basis. And basically the trajectory for Kessel Run has kind of been on an exponential growth since the beginning. I think we're now up to, I think 15 to 1,700 people in total with the program, working on legacy and modern software efforts with the entire program. I specifically, I run the engineering team who's focused on building the developer platform for the capability that we're shipping across the Air Force. So I spend most of my time working on kind of systems infrastructure, and the team's working on those tool sets to allow us to ship quicker. So kind of at the center of the DevOps patterns that have been coming to the Air Force basically since Kessel Run started. So the way we think about, at least the framing internally is like a lot of what we feel like we're doing is playing catch up, right? We're trying to bring in people who have industry experience, who have shipping software at scale across the commercial software industry, and bringing some of those practices that have kind of matured in those technology groups into the DoD, who is, I'm sure Ali, if you've spent time in you've spent time in IG, things are a little bit more advanced over there. That they might even feel behind as well. DoD is a little bit further behind there on our side. So we feel like we're playing catch up and trying to bring industry best practices into what DoD is trying to do to deliver capability quicker to our end users. So try to connect the use cases for the airmen and women who are on the front lines to the software that they have to do. So at the end of the day, that's what we're focused on, is trying to build products for our users. Our users just happen to be the men and women of the military who are responsible for keeping us safe day in and day out. And I think that's really important for our security and making sure that we can win the next war as we move forward.
Yeah, it's actually a really interesting point. Obviously, we do a lot of work with Kessel Run, and it's been really interesting to see at the pace which the entire program and the team has started to push and move forward, and especially being sort of very receptive and adaptive to a lot of essentially open source technologies that have sort of accelerate that. And maybe that'll be a really good question and transition. Amelie, so you've spent time on both sides of this, the government side, on the private sector side. Would love to get your perspective. If you think about sort of the DevSecOps movement, are there particular components of it that are very uniform between the government side and the private sector side? And are there particular pieces that really stand out, whether it's policy or technology that is difficult to adapt from one side to the other, that you see sort of clear distinctions between the two sides?
Yeah, it's kind of interesting. So, I've spent 2 cycles through the government, and the first one I left Interior and working in the White House to go work for Disney. And one of the questions I got when I got to Disney was like, what was different between a large enterprise like that and the federal government? And it's still, everything's very siloed. Everything's very political. Areas within Disney were just as walled off as you would be if you walked into a federal agency. Sharing communications and stuff is still difficult, getting everybody on the same page, using the same lexicon and so forth. So one of those cases is, while say like Disney looked to NIST as guidance, they had other things they were also going above and beyond, whereas government tends to sometimes just kind of hit the minimum low bar and consider moving on. The other challenges too, with a lot of development efforts, ends up coming down to how things are funded. Some components of agencies and stuff end up getting money that is only allowed to be spent within a certain year, and depending on when Congress grants the budget and stuff, and we're seeing that right now with like continuing resolutions, as soon as that's granted halfway through the calendar year, it's then a rush to get things done. So you're unlike, I think, commercial and private sectors where you can kind of carry on longer projects regardless if they're waterfall or agile DevOps type kind of base things. You start dropping features. You're only looking for like critical essentials, and sometimes you're not getting the best product because you're making decisions based on budget rather than technical capability or even what you're expecting on delivery.
Makes sense. One of the things that we've seen a lot in the industry is while containerization in Kubernetes has been a major accelerator for being able to build a lot more sort of on-demand services, consumption-based model, obviously being able to sort of preserve a lot of resources. At the same time, it's created and shifted the attack surface. Sort of my previous experience, a lot of the things we used to do was focused on, application exploits and vulnerabilities, focus on runtime. And actually the SolarWinds conversation has been a really interesting one because in my opinion, a lot of the shift we've started to see has been around the supply chain, specifically focusing even on tools that get incorporated into the developer lifecycle as part of this building lifecycle. And we've seen this across government and private sector. And Dan, you have a very interesting background across all things, blue team, red team, and all things offensive. Would love to sort of get your perspective as you think about sort of this new platform and this new stack, especially because it's no longer sort of just focused on runtime. We have to think about how developers build, how they deploy, and how you run. How do you think about this? Do you think there's particular areas in this particular workflow that are especially susceptible, that require more investment, or areas that you've seen specifically have major gaps?
That was you, Dan.
Oh,
Yeah.
sorry.
Yeah, I wasn't sure if I was certainly on mute or something. Okay.
No, sorry. Can you repeat the question for me?
Yeah, so what I was saying is that one of the major things we've seen by adoption of Kubernetes and containerization is the attack surface is shifted more and more from sort of zero-day exploits and vulnerabilities to more the supply chain, exposure of APIs, configuration, basically a much wider attack surface across build, deploy, and run. Based on your background, sort of how do you see this? Do you think areas exist that are especially a gap? And what are areas that companies in, whether private sector or government, that are doing especially a good job actually, resolving security issues with?
Oh, that's an interesting question. So when things started first getting hot and heavy for me was 2004 or something like that. When I got one of my first big sysadmin jobs, and I was tasked to build stuff for an automizer. And part of that stuff involved a lot of VMware work. And I want to say that VMware was relatively new at the time. And back then it was a matter of like, how do we improve performance? And it makes me think of way back in the day, like in the 90s, I discovered that it was one of my first experiences having messed with Linux. It must have been 95-ish. I figured out that Quake 2 ran 3 times as fast if I booted to Red Hat than if I was running Windows 95. And that it dawned on me that, the hardware that we run stuff on is capable of doing, let's say, X. And the further we abstract ourselves from our ability to harness all the power of that hardware, the less sort of performant we get. So the more shims we put between the stuff that we want to get done and the actual equipment that's doing the work, sort of the more performance hits we take. So we're sacrificing sort of performance for a combination of like convenience and there we're also adding like loads of attack surface, right? So when we're talking about doing things the right way and reducing attack surface and reducing risks, I see it largely as sort of a multiplayer event where I don't know that I can put my finger on any one specific organization that's like doing it right, as it were. So there's like several different efforts that are sort of asynchronous in nature, where you have like one group which will say, well, we've developed these new shims that will help reduce attack surface and allow administrators and network engineers and software developers to have access to more granular controls over something like, for example, Kubernetes. But largely, it's sort of if you let new stuff touch the internet, and this is sort of my bag, if you let new stuff touch the internet, the chances are good that it's going to break or something bad might happen before people are enticed to like build more security controls around it. So largely what I'm seeing is like, for example, if you just went to, pick your internet scanning search engine of choice and start plugging in new technologies, you're going to find that people are test driving this stuff by, say, for example, spinning up an EC2 instance in the cloud and saying, I'm going to put my thing in the cloud. And the attitude seems to be like, what's the worst that can happen? Like it's an EC2 instance, right? It's not connected to anything. There's no site-to-site VPN. Like we're not like, they can't, if somebody breaks in there, they can't get at us. To which, you know, I'm like, well, cool. I have a custom SSH keylogger that's for that specific purpose. So yeah, please keep putting stuff online. So it's sort of this like ebb and flow of like new tech comes out, new tech gets deployed, new tech gets steamrolled by attackers. InfoSec Twitter has an interesting laugh or a colorful Saturday afternoon or what have you. And then the next week there's some GitHub project around wrapping that thing that just was in the news because it got popped in some sort of security control. So yeah, I can't really put my finger on one specific company that's largely sort of spearheaded that effort. It's, from what I can tell, it's been largely a sort of a community thing where there's a lot of different moving parts and a lot of different players that are all sort of contributing to this sort of, I don't know, the best way I can phrase it is like wandering around in a big empty warehouse with a flashlight. Like there's a lot of space here and we can't see all that much because there's only one person with a flashlight and there's a whole bunch of us in this space and we're looking around. So it's sort of kind of, well, it's, what's that meme? I don't always test my code, but when I do, it's in production. It's kind of like that. So I know it's a weird sort of nebulous answer for your question, but that's my take on what I'm seeing.
No, I think that's a good answer. And sort of the way I think about this is that, you know, there are these buckets as far as like vertically integrated new technologies that ended up getting adopted. But I do think as we sort of think about the general concept of DevOps and distributed systems using containerization, microservices, and orchestration, I see that as a sort of a fundamentally new way to build, ship, and sort of manage your infrastructure. And Michael, sort of a follow-on question for you on that note is, one of the fundamental components of this is that I think if you're going down this path, regardless of whether you work in, you know, air-gap environments or you're working on a public cloud with a lot of additional resources that you can pull from, open source plays a huge part in DevSecOps. And I think the part that sort of becomes concerning is, how do you balance good hygiene of adopting open source tools, allowing your developers to be able to build and drive that, while sort of maintaining and managing the integrity of systems, being able to sort of have a verified or having some sort of a, you know, certification system for the tools your developers can use. So, you know, in a simplistic way, how do you actually adopt DevSecOps in government where there's such high bars for security while still sort of adhering to the core tenets of DevSecOps, which is really a shift left, developer-centric, community open source driven model, which Dan was touching on?
Yeah, and I think this is a really timely question too, because I've been thinking about a lot about this question around supply chain security since some of the announcements that have been going on this week with Sunburst and all of that. Yeah, so I think so we work with authorizing officials, right? At the end of the day, we've got the person taking a legal stake in what we're doing is an authorizing official who's taking a look at the things that we're doing, working with teams that are assessing the things that we're doing, and trying to make a gauge of a judgment of risk. How much risk are we going to take with the thing that we're building at Castle Run? So we've actually brought that process in which we engage with the authorizing officials into the DevSecOps process itself and bring them into the fold around making risk observable. So we using tools like StackRox and others that we can say, here, take a look at here's a good way of seeing what's happening in our environments at any point to help mitigate some of the risk observability problems that our AOs have. Like they just want to know, what are we actually running? What am I taking a risk on? Other things around like supply chain, for example, I come from a commercial background, so I'm actually pretty pro open source with respect to how the government should operate. One of the interesting challenges that we have is that we have a lot of money that we can spend on software that it's very hard to contribute to open source projects in that way. There's new models that are coming around with like sponsorships and those types of things, and those are interesting areas that I'd like to explore from a contracting and acquisitions model where we spend money on helping support open source, because I do think that depending on where you are in the stack, certain things deserve extra scrutiny. One of the questions I have after this week is, if you need privileged access to my, if you're running in Kubernetes and you need to escalate to privileged access into the onto the host to be able to do the thing that you're doing, running as some type of agent or observability tool, and it's built in a proprietary system. How, at the end of the day, we're questioning trust here, right? Like we trusted SolarWinds to provide us with, malware-free binaries that we could run on our networks, and that trust was compromised when, their build system was compromised. So now, thinking about how we're trusting the build systems of our vendors is kind of the thing that I start thinking about with respect to this week. And so probably those things that do sit in that privileged space. I mean, we've got this new model with Kubernetes that allows us, to unify policy and, detection capabilities across all of our cloud infrastructure, whether it's on-prem or public cloud. And we operate both at Kessel Run. Investing in those processes, the things that are sitting and needing privileged access, working with vendors, leveraging open source technologies where we can, to evaluate that code and what's actually running there. When I think about supply chain security, focusing on those parts of the stack seem to be the most obvious. I think it's going to be very difficult for us to achieve the speed of delivery that our customers are looking for, our users are looking for, if everything has to be assessed to the nth degree. That's the problem where DoD has been, where you couldn't make a change without having to go through a reassessment. And we're trying to break out of that model and trying to get smart about what are the things that deserve strict scrutiny, if you will, here in this case. And what are the things that we can use detection systems and use policy and observability to help mitigate any potential, issues, and where we have, 9 months of a breach and we don't even know about it. Those are the situations I want to avoid. So that's kind of how I'm thinking about it right now, especially after this week.
Makes sense. Amelie, you want to add to that? I think you might be on mute.
Yeah. So sorry. So I can kind of take this at a couple different levels up from that. So, as an acting AO, when I was CTO and deputy CIO, a lot of that's getting to the point of where we actually look at this authorization process, especially if you're talking anything within the government, is almost kind of policy hacking in a way. What they actually mean by substantial change. So that's I think kind of a difference maybe the executive branch had from, say, DoD on their requirements. But if there was a substantial functionality change, that would require an authorization. But if you were doing a library upgrade or something that was there to basically fix a feature, a patch or something like that, you didn't have to necessarily kind of go through that process. And for us, that actually helped us speed things up, because we looked at, when we were delivering stuff, as the original AO process, and then we would do addendums. So one of the things I structured with our CISO that we had gotten in there was, let's structure this as the initial authorization for a system that we're deploying, monitor it, we have our controls in place, but every time we want to kind of glom onto it, make a substantial change, the original would be there, the documentation process, what we'd go through, and then we would have an appendix or an addendum to it that would document those changes, that we actually had that kind of thread that we could follow. So in the case of, if something went wrong, we knew where it was, especially where the change was, and how, what the controls were that were possibly changed, or the risk that was accepted at that point. Then again, too, you're talking about Kessel Run. I'm wearing my U.S. Digital Service shirt, which one of the things I helped start back in 2014. And that was part of that aspect of, I felt like it was one army against the wind a little bit with getting open source into the federal government, getting a policy around that, how to integrate that in. You obviously could probably know that from the DoD, where, oh, well, it's open source, people from other countries that are not part of Five Eyes or whomever could contribute. Oh, we can't trust that. And it's bogus, because the idea conversely is that you have more eyes on that, there's a greater chance to actually find flaws. Also that summer was, where we had Heartbleed. And the challenge we have at that policy leadership level is, when someone says Heartbleed SSL, they immediately go, let's scan our websites. And one of the things, and I've told this story multiple times on Twitter, was after we got over that initial hump of, telling the agencies to go jump, I was also letting them know that a lot of these components, the OpenSSL libraries, were compiled into hardware. They were client side. So you had like iPhones and so forth that were using those libraries, that there is, it wasn't just a server side type of capability. And it's getting folks who are driving action, driving policy, driving those types of changes with programs and stuff like that, to understand that it's a whole ecosystem. It's not just part of that particular way that people are or think about how to use it. It's the whole idea with NTIA and Alan Friedman with the SBOM, the Software Bill of Materials, is having that ingredients list so that when you do have these vulnerabilities, you do have these incidents, you can easily kind of go look at a manifest and find out where this stuff is and remediate that, rather than this hunt and peck methodology that we go through. Security people don't scale. Even though we think we can run 24 hours a day on caffeine, there's a point at which that productivity and that capability drops off. And at large scale stuff like it was Heartbleed, we're seeing SolarWinds, plenty of the ransomware stuff is that there's just an upper limit to what we can do. So we have to work smarter. So the whole concept of DevSecOps is getting that greater integration of the point security knowledge of experts into participate in the development and operations side of the house, and then give some sense of ownership to developers and operations people to say, this part of this of running things securely or building things securely is you. We will provide guidance, and then when it gets to a point of where we need to help with architecture or we need to help with monitoring security, that's where we can kind of focus that expertise and scale.
Makes sense. So that's actually a really interesting transition point, and I would love to sort of change a little bit and dig a little bit deeper specifically on the technologies we're talking about, its security implications, and then I'll sort of open up the questions to the whole panel, so feel free to jump in. I'm not going to point it to somebody specific, but to your point, Amelie, one of the things I'm a huge fan of when it comes to leveraging containerization specifically on top of immutable ephemeral infrastructure is this notion, I feel like, that you can take actually security from the traditional probabilistic model of let's correlate logs and events and processes and system calls and try to make some confidence decision around what we think happened, to the more deterministic model where you can actually write declarative policies as to how infrastructure should run. And because you're running immutable ephemeral infrastructure, anything that deviates from that sort of that declarative state can essentially be either torn down, sort of killed by the orchestrator, or you can go off and sort of do additional investigation and forensics. And one of the key things that I think Kubernetes offers is Kubernetes obviously has this concept of pods where you couple a bunch of containers and you run it into a pod as a deployment, and then you replicate those out, but they all should sort of run the same way. And this is sort of what we call replica uniformity, which is, oh, now we can sort of drive down false positives by another order of magnitude by seeing, did somebody SSH into this pod, and is this normal for your dev teams to do this in these particular applications, or is it something that stands out? So I've become a huge fan of this, and obviously Kubernetes as its core has the concept of network security, network policies, pod security policies, and YAML, which is sort of the way you can describe a lot of this at its core. I would love to understand from the panel, are there particular measures that you think you can apply using containerization, Kubernetes, and DevOps that from a scalability or automation standpoint didn't exist in traditional spaces, but security teams for most part are not even applying those because they're sort of not aware of some of these constructs or core tenets that exist in this new infrastructure?
Yeah, I can take that to start. I mean, the first thing that comes to mind is the way we're doing configuration management for our clusters. We're using tools like Flux to do strong configuration management across all of our clusters. So we have central point of policy and management of what's actually capable on our Kubernetes clusters. That's been a really successful model for us. I mean, if we need a new cluster, we can spin up a cluster and it's pre-registered with our source code. All the templates and everything are ready to go to inject the like our baseline configuration, if you will. So getting agents and telemetry and observability stuff in place so that we can start seeing what's actually happening. We can use things like Open Policy Agent to write policy to say like implement things like pod security policies, for example, but do it in a way that we can collaborate with our security engineering team and say, hey, like we want to turn security into an engineering problem, and like rather than hunting around and trying to figure out what is what to poke at and what to try to see what's working, what's not working. Collaborate with security on people who understand what are the actual threat vectors that we should be thinking about in this context, and have them contribute directly to the code base as part of the contribution process to our release branches. So when we push out new configuration, we've got collaboration with both the engineering team who's running the thing and the security engineering team who's taking a look at what what is actually being, what's the implication on security-wise on our threat vectors that we're actually ignoring or we are considering in this process, and does it effectively accomplish that? So that's what immediately comes to mind in terms of really strong configuration management. The reason why I think this wasn't available to us previously is the declarative model around the API set, being able to say what the outcome I want is and have the control loops inside of Kubernetes actually go ahead and achieve that, I think is a powerful pattern and something that I think goes underappreciated when we talk about the world around containers and those sorts of things. That declarative model, I think, is uniquely powerful to help enabling some of these workflows so that we can centralize a lot of this, make it declarative, and have that outcome from a deterministic perspective match what you're looking for. I think I'll leave there. So
maybe sort of expanding from there, one of the things that Kubernetes gives is this notion of, high availability and a lot of very interesting use cases, but it also presents its complexity challenges. And Dan, one of the things you touched on previously was this notion of performance versus convenience. Would love to sort of understand from the panel, how do you think about usability and the trade-offs when it comes, the conversation becomes performance versus convenience? Obviously we would all love to be able to do remote hardware attestation and be able to ensure that what we're running is, completely secure all the way down to its root. But then that sort of removes a lot of the flexibility and agility that potentially developers can actually get with the stack if you sort of add these additional layers. So, is there a particular sort of framework that all of you think about when it comes to convenience versus performance and security? Or, is that even the right way to think about it when we think about containerization and distributed systems?
I have strong feelings on the topics of frameworks, in that they are largely authored by people that, to use a phrase that is very common on Twitter, is they don't computer. They're policy people that in some cases brag that they don't read email. And these are the folks that are writing policies that govern how we are supposed to compute securely. So not all of them are straightforward. Not all of them make sense. Not all of them are, very few are plain English. And the thing to grapple with when new technologies like Kubernetes and Docker have, can come out is, what do we get? What is the at the end of the day, what is the trade-off between what cool new features do we get? How are we empowering our business and our users and our admins and the people that have to feed and water this stuff? And what are we sacrificing in terms of how much new attack surface are we adding? What risk are we bolting onto the business? How much more overhead do we have to deal with? And how much of the system resources that we have available are we dedicating to stuff that maybe isn't doing the best job at taking advantage of those resources? So, for example, the last time that I had my hands on Kubernetes was to do an assessment where there was an organization that hired us. They had a managed Kubernetes offering that they were bringing live, and they wanted us to beat up on it before it went public. And one of the things that I was doing the last time I had my hands on Kubernetes was container breakouts. So things like everything talks to the internet now. You can't, some people can't, they complain openly that they can't turn on their lights because their light bulbs want a firmware update. Or was it 2 weeks ago, roughly, when US East 1 went offline and people couldn't use their Roombas? Like, you can't vacuum because the internet is down.
Oh, there was just yesterday with Google with lights. So
oh, yeah. That's the world we live in now. So like how okay, like we're going to deploy Kubernetes into a hardened air gap infrastructure that is the sort of scenario where you have dudes with guns outside. Mm-hmm. It's not connected to the internet. What do you do? Like, everything that you need to do to orchestrate setting up a container. Oh, well, that goes out to the internet. Well, you can't do that. Okay, cool. How useful is it for us now? So like, there's a lot of really weird sort of contentious, like precarious footing sort of scenarios that you can envision when you have like, and I'll say this openly, I have next to no actual experience with the military. I'm just some hacker kid from San Diego, but like, there's bits and pieces of things that I do know, and largely is that when dealing with computers and the military, internet access is not always guaranteed. Mm-hmm. And then there's certain scenarios where maybe you can get it through proxy, or maybe you can't because you're on a boat or a plane or something, and it just doesn't have connectivity. So grappling the need for new technology to assume that the internet is present is something that will become an inflection point in topics of conversation surrounding using new technologies like Kubernetes in places that are, for example, like heavily air-gapped networks. So like the other side of that coin is, all right, well, we'll set up an environment and we'll let that environment talk to the internet so that we can install the containers, and then maybe we'll run with them until internet is required, and then we'll treat it like a faucet. We'll turn it on, turn it off, like a big Frankenstein switch or what have you. Well, it gets interesting quickly because to give you an example, like I mentioned attack surface in the past, or like, how do you grapple with the addition of this new interesting attack surface? Well, if you're familiar with stuff like SSRF and CSRF, it gets pretty wild when you're, for example, reflecting requests off the inside of a container to hit the privileged inside a kubelet API to do things like enable or disable network interfaces, or to change routes, or to change rules, or to change ACLs and things like that. So you get into this position where if you twiddle the bits just the right way, you can have a container on the inside of the Kubernetes infrastructure take malicious actions on your behalf. One of the more successful approaches that I've seen in this regard is in environments, again, that assume that the internet is present. Just install like Parrot or Kali or something inside of the pod, and then cool, you can, the infrastructure is designed and built to be able to trivially pull down stuff from the internet and like deploy it into use, which is cool. So I can put whatever I want in the cloud and then deploy that into Kubernetes. Now I have my tool set delivered on Rails by the system as it was designed, similar to how you mentioned SolarWinds. You expect that the DLLs that their software installs are free of malware. Well, it's kind of the same idea. With Kubernetes, it's a bit more open in that the people that are running the thing have the ability to, well, effectively deploy whatever they want. And this technology is so new that I have not seen a whole lot of control, other than like rule-based access control, the RBAC stuff that they built in recently. I'm not seeing a whole lot of stuff in terms of like being able to like, we've been doing web content filtering for a billion years, right? So web content filtering, you can easily like wrap your mind around and say, oh, there's websites that fit this category and websites that fit that category. And we can do filtering and blocking at a given organization, saying like, this department can only go to this website on their lunch hour or what have you, that sort of thing. Well, we don't have that sort of technology, at least that I'm aware of. We don't for installing packages in the Docker universe. Like, you can't say right now, I want to flip a switch and say our Kubernetes infrastructure will prevent anybody in the system from attempting to download and install Kali Linux or Parrot Linux as an attack tool set into our infrastructure, and alert us if that's the case. Like that plumbing doesn't exist. So this goes into the docket of pros and cons, right? Like, you're going to deploy this new infrastructure in a highly sensitive environment. Like, what are the risks inherent to the effectively scaffolding that you're installing, and what sort of shenanigans can we get away with by swinging around in that scaffolding? And what is it going to be exposed to? Like, for example, and I know this is probably a crazy tiny edge case, but there was recently one of the Google Project Zero engineers, Ian Beer, if memory serves, released an exploit that he was able to wirelessly crash every iPhone that was in like earshot of his radio because of a bug he found in their Wi-Fi meshing protocol that is a custom protocol that allows Apple devices to all talk to each other when they're physically close. So like, take that concept of like, you can brick an iPhone by being in radio range because you can send it packets that it doesn't expect. And if you combine that with technology like Kubernetes, that I would say isn't super hardened yet. When you start sort of monkey islanding these concepts together, you find yourself in a position where like, well, we're starting to be able to connect dots to get things, to find ourselves in a sort of SolarWinds-like scenario where If you know what's in play under the hood of a piece of equipment or a plane or a boat or what have you, and you know that there's other periphery attack surface that you might be able to get at, you can start basically working your way towards the middle and start to say, well, based on what we know of a given environment, like how can we potentially worm our way towards connecting the dots in the center and gaining control of something, or exfiltrating data, or collecting data on whatever. So use your imagination, right? So like that's what's the trade-off? Like how cool is the new tech and how badly do we want it versus like what is the risk of it actually getting popped? Who's it going to be exposed to for how long? What regards? How are we tracking that? So like these are the sorts of questions that when I said earlier that I get the direct impression that the people that make the policies don't really computer. I imagine that this question posed to them would yield a lot of question marks. So things get pretty wild fast, especially because the things in this space move very quickly. So in the process, like Amelie was saying earlier, that there's a lot of bureaucratic red tape involved with making changes that could be as simple as patching. Well, cool. So how long do those bureaucratic changes take, and how much overhead will that add to an environment where in the course of, say, 3 months, we can go from everything's great in Kubernetes land to, oh my God, everybody's doing container breakouts and people are posting POCs all over InfoSec Twitter, and there's like 10 GitHub repos full of it. So like the system that's designed to manage, like, how do we grapple with the risk and how do we compute the risk? Like, how do those decision-making processes cope with reality where outside of, your sort of military and government infrastructures, the world seems to be moving like 5 times faster. So it's an interesting sort of give and take.
Got it. So it's an interesting point because I'll challenge that because I actually disagree with that.
Okay.
And part of it is that it goes back to something that Michael mentioned, which is around some of the things around configuration management around Kubernetes, right? So this sort of also leads down the path of some of the things that Amelie was talking about, which is that if we take, for example, Kubernetes into consideration, right? Like, there's a number of things you can do to prevent some of the things you talked about. Like, you can put in linting when the developers are building something. You can use mutating webhooks to use admission controllers from deploying certain packages. Even at runtime, you can actually set least privileges mode to ensure particular processes or packages you can't run apt-get or curl or grab anything and actually install that. You can enforce, for example, beyond like RBAC, least privileges mode to ensure containers can't get root. And you can then do things like scale to 0. So I actually think that all those capabilities exist, but to your point, Kubernetes doesn't come out of the box configured for security. It comes out essentially completely with a permissive attack surface, enabling all these things to happen. But it does have really great controls to lock a lot of this down. So, this sort of transitions to a question I have, which is, are there particular recommendations all of you have when it comes to the most secure Linux distros? Or, if users are thinking about, for example, best use of Kubernetes, should they go out and roll their own kube vanilla distro out, or should they use a managed service provider? Or should they work with Rancher or Red Hat to roll out something that is more hardening around network policies? Because I think these are all the layers of the stack that actually exist that can contribute to solving that problem, and not sort of let people have free reign when they drop into a container and potentially break out of a namespace. So would love to pose that to everyone. Amelie, maybe we can start off with you here.
Well, anyone who's been around security long enough and, comes to the mantra of, prevent by default. So the idea of starting with something more secure and then, lifting the tape to let stuff out is going to yield you a less deviation from what is expected. So, one of the things you're talking about with Kubernetes is the advantage it has is that there you can, the microservices and the pods and stuff, you're down at an atomic level. So the thing is that the less a piece does, the more predictable it is. And that is the strength, that's the scalability and so forth. And, if you keep expanding that, and, Dan touched on it, and I think Michael will touch on it too, you do have those attack surfaces as you're asking it to do more things, there's a greater chance for things to fail. We're talking about some of the restrictions, say in the DoD land. I came from law enforcement as well as critical infrastructure, and power plants don't like to go down. So the idea is, as much as you want to do air gap, the stuff that runs power plants is very, very basic. And to get something to change there is, you instrument, you monitor it. That's the whole thing with the control rooms. Anybody who's watched Chernobyl this past year, one of the things is they weren't taking those signals, they weren't reacting, they weren't trusting them. We don't have to get down to the point where we're actually, micromanaging policy down to the pod level, down to the microservices level. As long as we start with a deny and a reduced, capability to begin with, we document the exceptions, and then we look for the aberrant behavior. So that's, I'm not going to pump my own company here, but the key thing I've given in talks is instrumentation is key. It's very easy to go and put something in there, watch it, as long as you know where you're getting the best signals from. And if you know what's predictable, what the business rules are, what's expected out of the system, it's very easy to then go react to that instead of having to kind of like swap flies every time you think something's gone wrong. And this is where SREs get the chance to kind of earn their keep here, is that the whole idea is for them to just make sure the stuff runs. And if they know what is expected of them, when something goes wild, then they can run their playbooks. They can kick off something on a response console or something like that, and that actually makes it much more manageable. Allows you to scale, allows it to be much more usable, and you don't have to sacrifice performance and scalability for the convenience factor. That is always the balance. I mean, I came from a UX background when I graduated college, but I was originally a computer engineer. And that's always been that battle of like, what are you exposing for people to make it friendly versus what are you making it to be usable and sustainable and resilient? And I think that's our biggest challenge right now, where we find ourselves in here. And obviously, any vendor who's had to issue an 8K as part of their filing for the SEC this year has realized that maybe we kind of have to work on finding that balance to ensure that we maintain that trust with our customers, but also make it a technology that people want to consume and continue to use.
Makes sense. So I know we only have about 10 minutes left, and I want to get to some of the questions that have come in from the audience. One of the main things that has been asked is, how does everybody see this evolution of containerization, Kubernetes, as far as orchestration goes? And maybe sort of just to narrow that question a little bit further, I want to actually sort of expand on something Dan said and get everybody's feedback, which is this notion of, for example, web filtering. I think one of the really great technologies that is complementing Kubernetes and generally orchestration is this notion of emergence of service mesh. Sidecars, things like Istio and Envoy, where you can do a lot more at layer 6 and 7, where you actually have the ability to deal with things like managing keys and tokens and secrets within the application, understanding down to the fundamental level, are my developers passing, for example, secrets as environmental variables versus properly using a particular vault. So would love to sort of hear from everyone as you sort of think about the evolution of containers and orchestration, maybe in the context of service meshes, maybe in the context of developer tools. Are there particular areas you see that are really exciting specifically for security?
I like the idea that you can quickly deploy sort of like custom tools that will do simple scanning, data gathering, telemetry, that sort of stuff, with basically like a bash one-liner, which is kind of handy. So you can say like, and this is something we're working on internally. We just released a product that does external risk surface enumeration and discovery, and we're working on like an internal version of the same. So the concept of saying like, we don't need to ship you a box, you don't need to buy our appliance, like that's 1980s thinking. What are you doing? Like we live in the future, we should act like it. Spin up a VM, drop this one-liner on it. Or hey, if you have a Docker or Kubernetes infrastructure, install this container and fire and forget. And it becomes immutable. It spins up using something interesting like Nebula VPN. Super simple, one line or like one file config, or like you can have one binary that runs the thing in a single like YAML config file and call it a day.
It's Unix all over again. The idea of a application does one thing and does one thing well. You don't have to have it do everything.
But then again, you're what's the give and take there, right? Is like we're making the assumption that the internet is always there. So if you find yourself in a position where like, well, the only thing available is satellite and we're not Inmarsat or whatever, they want $80 a meg, and no, that's not in the budget, or it's going to come down at X modem speeds, and we're like, no, we're done with the 90s, that we left them behind for a reason. But like it's going to drive innovation in the sense that like back in the day, you had, Red Hat was my first big experience with Linux. And then I punched out a Red Hat, went to Debian, and then I've been on Ubuntu since. But like watching the refinement of package management systems has been really interesting, because I remember as a kid having to do all my own RPM interdependency checking. Like,
Aw.
when you remember running
Oh,
like
I came up through BSD, so we had that worked out with the ports
Oh.
tree immediately. So
well, you got to wait for everything to compile. At least I got binaries, but like
and binaries too.
The idea there is like, at some point people decided, well, we need our own repositories. We need stuff that we can pull, build container, like not containers, but we're getting to containers, but like an apt package or a .deb or like a .rpm file. Like, we have the capability exists on that side of the house to say like, well, cool, we can set up a mirror internally and we just sync that mirror to the internet once a quarter or whatever. We flip the Frankenstein switch, the internet comes in, we do things, then we disconnect it again, and like good luck phoning home from there, malware. But if it's physically disconnected, then you have this like store and forward equivalent of like storing packages, right? And you can do that now, and I'm looking forward to seeing that sort of thing come for technologies like Kubernetes, because the idea is to say like, cool, we have, disk is cheap, whatever, you chuck a 14 terabyte spinning disk drive in there and then pull down the top 14 terabytes worth of interesting containers from the internet and stick them on in a cache somewhere in a data center. And then you have a link to that data center. You're not talking to the internet. And I don't know, I'm speculating at this point. I'm not sure if this sort of technology exists or is on the way, but like conceptually, if we're going to treat containers the same way as we're going to treat operating system packages, then functionally, like, the scaffolding sort of exists already from a conceptual standpoint, that like other organizations, there's other technologies that have done this already, and like the Kubernetes universe can follow suit. And I think it would be very successful in that way, to say like, hey, we have this locally accessible repository of like gold image style preened, audited,
Bust and assess stuff. Yeah,
exactly.
I mean, that's we've pushed for that. That's like the not the NVD, but basically, it has those the hashes and stuff like that. Like, you could pull stuff down, check it, and whatnot. But that is, it's one of those cases where you're in a restricted access environment that you at least have to have that. I mean, we did that for IG with one of the imports we had, one of the Python imports we had, where we were accepting what was being compiled, but when there was a patch release, we wanted to track that. So we had our own secure build thing. So if the vendor wasn't creating trusted binaries fast enough, we had our own exception process for us to go through that verification and acceptance, so that we weren't waiting for the vendor to basically produce something.
Yeah, and you get into like weird. You remember, like, God, a million years ago, I remember reading an article about how a Mafia Wars virus made its way onto the terminal that Air Force pilots were using to fly drones, because one of the people who was stationed there was bringing a USB stick in and plugging the USB stick into it was plugging a USB stick to the Windows box, because I think it was like MP3s. Dude wanted to listen to MP3s or something like that. And it was a shared physical piece of media that was shared between a completely air-gapped machine that was flying drones with Hellfire missiles attached to them, and like dude's machine at his house. And somehow, and golf clap to the malware authors of Mafia Wars is important enough to write malware that will hop across media, which that's impressive. But
so actually, a question on that. When we talk about sort of air-gapped environments, one of the questions that came in is, if we think anything that touches the web or potentially has connectivity presents, let's call it, an exponentially higher level of risk, how does government specifically go about modernizing a lot of these, traditional stacks, whether it's industrial control systems or whether it's potentially environments where they're trying to sort of just generally modernize a total stack? Like, what's the let's call it the quick answer or the actual strategy around this?
Michael, you want to take that one?
I think it's difficult. I think so. I don't do a lot of work on aircraft specifically, like control systems on planes and things that fly in the air. But we do work on air gap networks, and working on those networks difficult to achieve some of the types of reliability goals around the network availability and those sorts of things that be very difficult to do the things that we expect from virtual internet backbones. But I think the simple answer here is like look to companies like SpaceX who are doing interests around how to do hardware development and how none of that necessarily requires direct access to the internet. That could all be air gapped on their own private network without having to touch those sorts of things, but taking the principles of control loops and cycles and try to do modern software development inside of environment around hardware. To be quick on that.
Makes sense. So we only have a couple of minutes left. I just want to turn it to the panelists to see if there's any sort of final words of wisdom you want to put to our audience.
Try and break it yourself. If it's especially if it's a security appliance or security tool, like let's remember how Hacking Team got popped, right? Like Phineas Fisher got into Hacking Team through ostensibly what we think, because it wasn't made public, was their Barracuda appliance. So like, and then like the thing over the weekend, SolarWinds got popped and a bunch of places got compromised because an IT tool that they were using, supply chain attacks. So like, just never presume that a thing is safe because somebody told you it was safe. Like check for yourself.
Keep testing.
Yeah. Oh, and PCAP everything because if
makes sense. Amelie?
Conversely, I'd run a little bit counter to that too. I mean, I guess we did touch on open source, and I've been actually on this soapbox for many years. Is as much as we think of some of the software as free as in air, it's the fact is that as we learned from Heartbleed and in many of these projects, that it's a small shop that's usually governing commits and so forth. If you're going to go and use it and you're an enterprise customer, you're thinking of getting away using something for free or very little cost, contribute back to those projects by offering money or support for a security assessment. It's a lot cheaper to get one of those done than going paying licensing fees sometimes to Oracle for stuff. So if you want something that scales and does something better for the community, invest in your open source software in kind of a more unique way. So and that keeps people who have free time, like some of us on weekends, to go and do those assessments and write reports back. But at least we know that there's actually some interest there.
Makes sense.
Yeah, I second that completely. That's the one thing I would love to be able to do better than what we can do today right now with the government about funding projects like that and making sure that they can get supported in open source. Other point is just stressing that, there's not a silver bullet here. There's not one tool or one thing that's going to solve the problem. You got to look complete end to end and make sure that you're doing your due diligence and making sure that you've got, a continuous process for, in my case, and getting people trained up on modern security practices so they understand what's the best thing that we need to do, at every part in the stack of the development DevSecOps lifecycle, so we can introduce security at every point, since it's not going to be just one spot, it's the entire process.
Makes sense. All right, I think that concludes our panel discussion. So I'll turn it back over to Phil.
Yeah, thank you. And thank you to all of you for what I thought was a great conversation. One of the things that we want to try to engender with these is a conversation, right? So that folks that are listening don't have to just sit and listen to long explications and presentations and whatnot. And one of the things we want to try to make sure is happening is a back and forth. And I thought that was one of the most useful pieces of this conversation today, was the fact that you guys were actually able to engage down into the weeds a little bit on what is clearly not an easy set of issues, right? I think the thing that really inspired us, and Michael, this is kind of to you and the crew at Kessel Run and the folks at AFWorks, was when we saw that announcement of Kubernetes being used with the U2 and everything, Dan, that you were bringing up in terms of the challenges inherent to deploying these things in these incredibly sensitive systems, right? It's a real question that hangs out there. How do you do that and make sure that these things aren't caught later flat-footed? These are incredibly powerful new techniques, and the opportunities are rich, but is it really necessary? How can you do it so that you've actually done the trade-offs effectively? So thank you all for joining us here today. Ollie for moderating, to Amelie, Michael, and Dan, thanks for taking the time. I know things are crazy for everybody right now, so thanks for being here today. Everybody who's watching, we're going to continue a series of these sort of cyber pop-ups so that we'll have more discussions down in the weeds like this. Thanks again for joining us here today. Look forward to hearing from all of you. Take care. Please be safe.
Everybody.
Everybody.
Thanks, everyone.